So the last section for chapter 8 is applications of polynomial equation or using factoring to solve equation. When you get to this lesson, you have to solve these polynomial equations using all of the factoring techniques that you learned up to this lesson. So for example, 1 here, if you have an equation that it says x squared plus x minus 6 equals 0, you're asking to find what value of x such that, you square it plus x and then minus 6, which equals 0. We can sit here and trying to guess the value of x and then plug it in, square it plus x minus 6, and hopefully at some point we're going to get 0, and that would be the solution. But that way it's going to take more time. It's going to take longer. So instead, what we do is we say, okay, well, we know this from algebra at some point before this class. Maybe we haven't heard this, but it's called the zero factor, property. Right? This saying that, hey, if we have a times b, two numbers multiply such that this product is equal to 0, then either a is equal to 0 or b is equal to 0 or both equal to 0, because the or statement is kind of saying, hey, either one or the other or both. So what we're going to do next is applying the zero factor property with these equations. We say, okay, is there any way we can rewrite these polynomials as a product of its factors? And the answer is yes, and that's what we're doing, everything up to this point. So we say, okay, well, I learned how to factor a trinomial. So you say, okay, this is going to be x plus 3 times x minus 2 equals 0. So the left-hand side can be written as a factor of x plus 3 times x minus 2. And then we apply the zero probability factor and say, okay, well, now if I have my a here and my b there, then either x plus 3 equals 0 or x minus 2 equals 0. That means if x plus 3 equals 0, then x is equal to 3. And then over here, x equal 2. And those are my two possible answers for this equation here. So if I take either 2 or negative 3, I plug in for x, I'm guaranteed that when I square it, I add to the same number, subtract 6, I'm going to get 0. So that's just a simple equation for polynomials using factoring. When we get to something like D, okay, where it's already set up where one side of the equation has a product of two factors multiplying and is equals to 14. The problem with this is that sometimes students make a mistake of saying, okay, well, the zero factor probably is saying that, hey, I just set these factors equal to 0 and solve for x. But there, we have to make note that the property said that it has to be equal to 0 on one side. So in part D, one side of the equation is not equal to 14. If we're saying this is my A, this is my B, and we say, okay, well, either A equal to 14 or B equal to 14, this is wrong, because if you have two numbers multiplied to get 14, let's say A times B equal to 14, it does not always guarantee that one number is equal to 14 and the other one equal to 14. That's not always true, because if you have two numbers multiplied to get 14, you can have both numbers not equal to 14, right? So doing this is not correct, right? So when we follow the zero factor property, we have to make sure that, hey, is one side of the equation say that the product equals 0? Well, in this case, the product's not equal to 0, the product's equal to 14. So what we want to do is we want to make sure one side of the equation equals 0 by fully simplify the left-hand side. So we use FOILing. So this gives us 2x squared minus 2x plus 1x minus x equal to 14. 2x squared minus 2x, 1x minus 1. And then we subtract the 14 to the left side. So now we got the right side equals 0, and then we get 2x squared minus x minus 15 equals 0. Okay. Then we're ready to factor the left-hand side, so that way we get a product equals 0. Okay. So 2x squared, I can split that into 2x and x. Negative 15, I can do 5 and 3, 3 and 5, 15 and 1. What do you guys suggest as far as the two factor go here and here to make this work? Any suggestion? What should goes there?
5 and 3.
5 and 3. Where are the 5 and the 3?
Both are negative.
Both are negative. We don't want both to be negative because we want the 5 and 3 multiplied to get negative 15. So one of them has to be negative.
Okay, then 5 negative
Okay.
plus 3.
Okay. So you want to put a negative 5 here, you said?
Yeah.
And then plus 3 there?
Yeah.
Okay, will that work? Let's just mentally check this real quick. Our middle terms will be 2x times 3, and then negative 5 times x. So we got 6x and then negative 5x. That will give us a positive x. We want a negative x in the middle here. So what can we do to make it work here?
Negative 3 and positive 5.
Let's try that. So negative 3 and positive 5 will work now. Okay. So now we got the correct factors, and the other side of the equation equals 0. We can go ahead and say, well, according to the 0 factor property, the 2x plus 5 equals 0, or the x minus 3 equals 0. Therefore, our answers are negative 5/2 and 3. So make a note of that when you have polynomial equation and you're given an equation where one side of the equation is not already 0, you got to make sure that you simplify and then subtract the constant from the other side to one of the side of the equation and make sure it's equal to 0 on one side. If there are polynomial equations that involve more than just 3 terms on the left here, where the polynomial is not trinomial, is not binomial, but it's more than 3 terms, in this case 4 terms. One of the techniques we learned in 5.3 is that we factor by grouping. So since there's no GCF that we can take out for all 4 terms, we can say, okay, well, let's look at these terms as pairs and take out the GCF from each pair, right? So we say, okay, let's group this here and then that there, and then take out the GCF from there. So 2x to the third minus x squared, the GCF for that one will be it's going to be x squared, and then that will give me 2x there, and then minus 1, right? So this here can be written as x squared times 2x minus 1. Over here, the negative ax plus 4, the GCF in this case is going to be a 4, but because the leading coefficient is a negative, instead of taking out positive 4, we are going to take out a negative 4. So if our GCF is negative 4, we write minus 4, and we say, okay, well, let's see, negative 4 times what give me negative 8x, negative 4 times 2x give me negative 8x, and negative 4 times what give me a 4, negative 4 times negative 1 give me a 4, okay? So now, if we do this step correctly, we should recognize the next common factor to factor out. As you can see that both terms have 2x minus 1 in common. Now we can factor 2x minus 1 out as a GCF. Okay, we said that is my GCF. Okay, if I factor out 2x minus 1 for the first term here, the leftover factor is x squared. And then if I factor out 2x minus 1 for the second term, my leftover factor is going to be a negative 4, right? All right. So now we have a product of 2 factor equals 0, but we also learn how to factor different square in 5.5, I believe. I just uploaded that video yesterday, but I think many of us already complete that sections. So if you recognize a difference in square factor, in this case, this binomial here, x squared minus 4, before you finally solve for x, you want to factor that binomial even further. So you say, all right, my x squared minus 4 can be factored into x plus 2 and x minus 2 because it's a different square. So now I'm ready to solve each of this to get the x value. So the answers are plus or minus 2 on this side and 1/2 on that side. All right, any questions so far there, guys? I am recording this so I can upload this on YouTube in a bit so you can review this later. I won't do B in exercise 2, but I'm going to give you a hint here. When you solve a polynomial equation where the polynomial within the equation contains fractional coefficient, like this one here, the very first step, what you want to do is you want to eliminate the fraction coefficients. So since we have an equation, we're allowed to multiply an equation by a constant, and it doesn't change the solution. So what you want to do, the very first step for this problem is that, hey, what number I can times to each term in this equation or both sides of the equation, so that way I am going to cancel out all the fraction. So what number should I times here? What do you guys suggest?
18.
Yep. If I times each term by 18, I'm guaranteed to eliminate all the fractions. So now, the equation I'm trying to solve for is much easier to manage, right? It can be factored easy. Okay. Another type of example you may see in the homework is the question is written in the form of function notation. It's kind of confusing. And that is what exercise 3 is saying. That it's saying that suppose we have a function f of x equal to x squared minus 4x plus 6, and we ask to find the values of x where f of x equal to 11. So, you know, sometimes we read this here, we don't really read the wording, we just look at the two things that within the problem, those are the number, the math part, and we just do some random stuff with it, and hopefully we'll get it right. So the mistakes that students often make when it comes to this type of problem is they just do this here. They do, all right, well, I think this is what the question is asking, right? Whatever that come out to be, 121 minus 44 plus 6, and they say, well, the answer is 83. Right, when you do this kind of stuff, you gotta make sure you look at your work and kind of read the question and say, okay, well, the question asks for excuse me, the value of x. So I mean, we don't know what x is. So how are we gonna go ahead and just use this as the x value? We're supposed to solve for x. X is not given, right? So what we did there is mistakenly use 11 as x, where the questions ask us to find value of x. So this is not what we want to do. Okay. So this saying that, hey, what value of x? What value of x? Okay. When we plug it into here, we get the output. We get the output to be 11. Okay. So what x give a y value is 11. So it said what x or x such that y is equal to 11, because f of x is y in this case. Okay, so we just set y equal 11, and then solve for x, right? So that's the correct setup. Okay, you want to isolate one side equals 0, so that way you can factor. All right, so use factoring. I think I got it wrong. So 6 minus 11 is -5. That's where I went wrong. So my 2x are -1 and 5. So in terms of the graph, if I can sketch this really quick here, I don't know what the graph look like, but I do know the y-intercept, so it's gonna be there, and it's gonna be open upward. So I'm gonna say this is my graph, something like that. The 2x are -1 and 5. That will produce 11. So that's what we just solved for. What value of x that will yield, or that will correspond to an output of 11. Okay. This may be not the correct graph, but you can see a quick visual of what the questions is asking there. Okay. I don't know if I assigned any word problem in the homework for this section. There's yeah, so Cam Scan app is a good one. I think I include several other ones in the syllabus. Faza, Fiza. There's a lot of different names that I suggested. Okay. So, do you think this will help you get started with 5.8 homework for those who haven't got started, or the ones who already complete 5.8? Do you remember doing this at all in the homework?